So next up, we have Ben Yu, who's going to be talking about WeScheme and Technicolor structures.
Thank you. So yeah, I just want to give a little talk about what I did for my summer this year. So basically, I worked with Shram's group at Brown. Worked with called Mongolian Horde, 2 groups, to implement 2 different projects. We wrote an authoring tool called DrBlocket, which I'll talk about in this talk. And we worked on another project, multicolored highlighting, which I'll give at 3 o'clock. And they're not really connected. There's like this overall idea of attacking the tyranny of flat structureless strings. Instead of using string representation all the time, we're using structures. So I'm going to be talking a little bit about DrBlocket. So first, I need to talk about what the problem is. In how to design programs, we're teaching students how to write programs. And often they run into the typing issue. They really can't type the programs very well. Not only are they slow typers, they're imperfect typers. And so they'll miss parentheses and sort of, you want them to get the balance right, and they can't do it. So a lot of beginner level programming environments have attacked the editing, the typing problem by doing something like Scratch, by providing a structured editor. And we saw Scratch earlier, but just to see what this environment looks like, you have a set of blocks of composition and ways of snapping the blocks together. And you notice that a lot of the commands are very imperative. So Scratch, for example, doesn't allow us to do a how to design program style curriculum, one based on testing on writing functions that produce values, on being able to test the output of those functions. So Scratch is a little bit limited in what we are allowed to say in them. So what we would like to do is provide a Scratch-like block language, but one that also supports the goals of how to design programs. So let's look at how what this might look like. Well, we mocked this up, and we would like to be able to have the blocks and use color in order to specify what kind of thing belongs in what block. So for example, here you would use blue to specify a number can go into this block, or in the terms of the string, a string can fit into an orange box, and so on. And we want to provide how to design program support. So what does that mean? We want to support contracts. And in that sense, the contracts are not just this static passive entity, but they actually are something that is active. If you say, I want the input to be a number, that should force the color of the value of the body of this function to be restricted to numbers. If you try to put a non-number thing into the number box, it should reject that. And similarly, if they're writing conditions, we should be able to add 5 in as a number and have it automatically figure out that that the color is consistent within both answers.
Can the answers be of distinct type?
And we would also like to be able to, so of course, support disjoint data types. So we would have to.
So you see green and red in one answer.
Union.
Yeah, we would like to have a union.
You don't have it.
Not yet, but that's the plan. So let me give you a demo of what we've got so far.
Disagreement on the plan. I like that. Takes time.
So here's DrBlocket, and on the left-hand side you see a bunch of collections of drawer elements. And so, for example, we can drag elements like true and false, of course. What was that?
Are you in a browser?
Yeah, I'm in a browser. Let me make that a little bit larger. Is that good?
Yeah. Awesome.
And of course, we have the regular operations for adding numbers together. So let me just do 17. Let me show you that this is live, so you can run the program. Each block comes with its own result. So of course, true and false about that, and but of course, we can also work with images as well. So we do this, and I can drag blocks around. I like. What's my favorite color? Turquoise. Okay. Right. And of course, we can also do things with functions. So let's write a little function. And I'm just going to write the double function. So basically, it's going to be something that takes numbers to numbers. Let me just give a name for that. So that's a thing. And so basically, I'm going to just multiply thing by itself. So I'm going to just do this, drag thing there. And note that once I have a function definition called double, it shows up in my collection of number handling functions. So I can just use double here, and hopefully this will work. Let's see. Yeah. Okay. Good. And so the answer is, that's not what double does. That's square. Does what I coded it to do, not what I meant. I should have written the purpose way to square. Okay. Great. Anyway. Right. So of course, there's a lot of work that we have to do here. We have to iterate the design of DrBlocket to support things like disjoint unions. I said that we wanted to support how to design programs, and one thing that's missing here is test cases. So we have to add test case support as well. We would like to integrate this into WeScheme, the online programming environment that I've been working on. But I mean, most importantly, we need to measure the effect of this interface on real people. One thing that's been missing for so long is the evaluation portion. So we're going to be modifying WeScheme to capture the actions that people take in using this interface, and hopefully be able to give concrete, be able to collect concrete data on how these interfaces help or hinder students. And the code is available on GitHub, and you can just check it out. And I'd like to thank the whole team for working on this. If you have any questions, I'd like to hear them.
Can you scroll back to your previous slide?
Thank you.
Yeah.